The major thing we're going to take away from this section is finding domain and range graphically. So back in section 3.1, we learned how to find the domain of several types of functions from their formula, but now we're going to learn how to do it just based off of the graph. Okay, and another thing you need to recognize here, we're going to be finding the range now. Okay, in section 3.1, when I presented you those different types of functions, polynomials, fractions, square roots, cubed roots, those types of functions, and we talked about the domain, we never mentioned the range. And the reason is the range of a function can only be gotten from the graph. Okay, so you can only get the range from the graph. Okay, formula does you no good unless you graph it out, look at the picture, and determine the range that way. Okay, all right, so on this page, page 3, there are a lot of words, okay, that goes into detail about how to find the domain and range from the graph. There's a lot of symbolism on here that you should recognize from our domain discussions back in 3.1. Okay, so I will just read over it, but keep in mind you should know a lot of this. The top 2 bullet points are going to go into specifics about how you read the graph to determine the domain and the range, and then the rest of it, like I said, is more the symbols, open circles versus closed circles, parentheses versus brackets, and so on. Okay, so let's read through this, and then we will go through several graphs and identify, first of all, whether or not we're dealing with a function, and then write down the domain, write down the range. All right, first bullet point here has to do with domain. Okay, so it says the domain of a function is all of its x values. In order to find the domain from a graph, look at the x values of the leftmost and rightmost points of the function. That's the key here. Okay, you're going to look at the x values of the leftmost and rightmost points. If the graph consists of more than one piece, that means there's a gap. Okay, you're going to find the domain of each piece, and then the domain of the entire function will be the union of the domains. All right, next bullet point. The range of a function is all of its y values. In order to find the range from a graph, look at the y values of the lowest and highest points of the function. Okay, again, here's the key phrase. To find the range, you're going to look at the y values from the highest point, from the lowest point to the highest point. And again, if the graph consists of more than one piece, you're going to find the range of each piece, and then the range of the entire function will be the union of the ranges. Okay, all right, so let's keep going. You're going to write the domain and range using interval notation. Pay careful attention to endpoints, or whether the graph extends indefinitely in either direction. The symbol closed circle means the corresponding point is included in the graph. In interval notation, include the appropriate endpoint using square brackets. That is left bracket or right bracket. Okay, so this is important. Okay, we've already seen this. Closed circle means the point is included, and you should use square brackets. All right, next, the symbol open circle means the corresponding point is excluded from the graph. In interval notation, exclude the appropriate endpoint using parentheses. All right, so open circle means the point is excluded. You're going to use a left parentheses or a right parentheses. Okay. An arrow indicates the graph continues indefinitely in that direction. The appropriate endpoint in interval notation will be represented as negative infinity or positive infinity, and either preceded or followed by parentheses. We saw infinity and negative infinity. We were talking about domain in section 3.1. Okay, remember those are just symbols to indicate that your graph continues indefinitely in one direction or the other. You use parentheses on either of those symbols because they're not numbers, they're just symbols. Okay, all right. I am actually, before jumping into example 3, I am going to jump back to the graph that we saw in example 2. Okay, and what I want to do with this is write down the domain and the range of this graph. Okay, so let's start with domain. Okay, what do we know about domain? Domain is going to be all the x values. So really what we're doing here, we're trying to write down all the x values this graph covers. Okay, what you need to remember is that domain is done from left to right. Okay, so these are the things you need to remember. Okay, domain is all the x values, all the inputs. You need to write down, what you're trying to do is write down in a compact manner all the x values this graph covers. You absolutely have to do it from left to right. Okay, so here we go. Okay, this is how you're going to find the domain. You're going to find the leftmost point on this graph. Okay, well, here it is. Okay, you can actually physically pinpoint it. This is the leftmost point on the graph. Okay, this closed circle, it is included in the graph because it's a closed circle. It corresponds to the point -6, -3. Okay, so the x coordinate is -6, the y coordinate is -3. Okay, since this is domain, you're dealing with x value, so you're going to write down the x value. Okay, so the x value there is -6. This is telling us that this graph starts at x equals -6. Okay, then you travel to the right. There aren't any gaps. Okay, and we're going to get to the rightmost point. Okay, here is the rightmost point. Okay, right here. It has coordinates 11, 1. Again, this is a closed circle. You want to include it in the graph. Okay, so what you need to write down, since this is domain, you need to write down the x coordinate, okay, which is 11. Okay, so what this is telling us is that this blue curve exists between x equals -6 and x equals 11, and there are no gaps. Okay, so then you have to think about the endpoints. Do you use a bracket or a parentheses? Okay, well, if we look at x equals -6, that corresponds to this closed circle, which is located at -6, -3. Because it's a closed circle, you want to include this point. So you're going to use a bracket. Okay. If you go over to the rightmost point, 11, 1, also a closed circle. So you're going to want to include 11 as an appropriate x value. Okay. You plug in x equals 11, you will get the output of y equals 1. Okay. So 11 will be in the domain. Okay. That's it. Okay. This is telling us that the blue graph exists between all real numbers, fractions included, decimals included. Okay, all real numbers between x equals -6 included and x equals 11 included. All right, so now let's talk range. Okay, so I'm going to go down here and I'm going to talk range. Okay, range, we're dealing with y values. Okay, what you're trying to do here is you're trying to write down all the y values. This graph covers. When you do range, you're looking along the y-axis, you're looking at y values. Instead of going left to right, you're going to go from the lowest point to the highest. Okay, so let's give it a shot. Okay, when I go back to this graph, okay, and I'm looking for the lowest point, okay, I'm going to go ahead and erase this. Okay, the lowest point on this graph is right here. Okay, -6, -3. Okay, you're going to write down the y value for this point because it's range. Okay, so I'm going to write down -3. Okay, then I have to travel up to the high point, okay? So here is the highest point on the curve. It has coordinates 2, 4. You're going to write down the y value, which is 4, okay? So that's it, okay? This blue curve exists between y equals -3 and y equals 4, okay? You can think of it like, say you had horizontal lines right here, okay? This is through y equals 4. And then you had another horizontal line down here through y equals -3. Okay, the entire graph is sandwiched between these two y values. Okay, that's what range tells us. Okay, all right, so we're almost there. Okay, we've got the numbers that the y values go between. Okay, we need the endpoints. Okay, if you look at the point corresponding to y equals -3, that's this point -6, -3. It's a closed circle, so you're going to include the -3. If you jump up to 2, 4, because you're looking at the rightmost endpoint here, for y equals 4, this point 2, 4 is a closed circle, so you're going to want to include the 4. Okay, this is the range. Okay, again, this blue curve exists between the y values of -3 and +4, okay, including the two endpoints. All right, so that in a nutshell is how you do domain. Okay, but remember, you might see open circles. You could see one or more parts of the graph extend indefinitely in a single direction. Your graph might come in pieces. So we're going to look at all of those different types of examples. Okay, so let's go back to page 3 and start example 3. Okay, there are, I believe there are 10 graphs that we're going to look at. Okay, so for each one, we're going to indicate whether each relation represents a function, and then state the domain and range of the relation using interval notation. All right, so here we go in example 3a. We've got this line segment. One of the endpoints is a closed circle, so we're going to include that point. The other endpoint is an open circle, so that point is excluded from the graph. First thing we need to know is, does this pass the vertical line test? So again, you're just going to, practice drawing some vertical lines in and see how many times each vertical line intersects this blue curve. Okay, and you can see that every time I draw a vertical line here, I'm intersecting this blue line segment in just one point. Okay, you may be wondering, well, what if I draw the line segment, or draw the vertical line right here, okay, through that open circle at x equals 1? And the answer is that's just fine. Okay, you still pass the vertical line test here because this open circle is not actually part of the graph. So this green line is intersecting the blue curve one or fewer times. Okay, all right, so this line segment does represent a function. Every input has a single output because any vertical line intersects the line segment in at most one point. Okay, let's jump to domain. Okay, we need to ask ourselves, what x values does this graph cover? Okay, so we're going to look at x values and we're going to travel from left to right. Okay, so here we go. Let's find the leftmost point on the graph. Okay, well, that's going to be right here, this point right here. Okay, I'm going to write down the coordinates of this point. This point is located at -2, +8. Okay, and since I'm doing domain, I need to write down the x coordinate. Okay, so for this point, the x coordinate is -2. Okay, and then I'm going to travel to the rightmost endpoint. Okay, that's right here, this open circle. This open circle is located at the point 1, 0. Okay, you need to write down its x coordinate, which is 1. Okay, so that's the interval. This is saying that this graph exists between all real numbers between -2 and +1 along the x-axis. Okay, we just need to determine the endpoints. Okay, so if you go back to x equals -2, that's this point. It is a closed circle, So you're going to want to include that point in the graph. So -2 is included in the domain. And then for the right endpoint, the x-coordinate is 1. This corresponds to the open circle. Since the circle is open, that point is not included in the graph. Therefore, we do not include 1 in the domain. Okay, so we put a parentheses. All right, moving on to range. We're going to be writing down all the y values that this graph covers. Okay, we have to work from lowest to highest. Okay, so when we look at this, okay, if you pinpoint the lowest point on the graph, hey, it's the open circle, 1, 0. Okay, so you need to write down the y value of this point since we're dealing with range. Okay, so the y coordinate of this point is 0. Okay, it's an open circle, so we're not going to include this point. So put a parentheses. Okay, then we're going to travel to the high point, which is the closed circle, -2, 8. We're going to write down the y coordinate, which is going to be 8. Okay, this is a closed circle, -2, 8 is, so we want it's included in the graph, so we want to include 8 in the range. Okay, that's it. We've written down the domain. We have written down the range. Okay, real quickly before we go on, I just want to make sure you understand what this is telling us. Okay, for the domain to be -2 to 1, that is telling you along the x-axis. Here we go. Along the x-axis from -2 to 1. Okay, in between these two red lines. Okay, I have one red line at x equals -2, and I have another red line at x equals 1. In between those two red lines, that's where the graph exists. Okay, and this is where it exists along the x-axis. Okay, so that's your domain. If you instead looked at the range, okay, and you draw a line, a horizontal line this time, through y equals 0. So if you draw a horizontal line through y equals 0, that's right here. And then you draw a horizontal line through y equals 8. Okay, this is the range. Okay, along the y-axis, this graph exists between y equals 0 and y equals 8. So now we're going to try more of these.